Hello everyone, welcome again to Hybrid Account. And today we're just going to take a look at the second method of computing correlation coefficient called rank method. Actually, it is also named as Spearman's method as following the one who established such a method, right? Okay, so we show that the product moment actually can be used to measure the strength of any relationship between variables, but also the rank method can be used. And actually, we'll see the points at which it is much more useful than the product moment method. For example, maybe you are given data that is not reliable, right? Maybe you are given data about advertisement and sales, but actually the cost of advertisement and revenue from sales are not so reliable. So it's better to rank them. Just take a look at which is the first one, which is the highest, which is the lowest. Rank them. Maybe this is the first, this is the second, this is the third. That way, right? Yes. Or maybe you are just analyzing qualitative data. You might be having data that is qualitative. You just need to analyze it. So instead of quantifying it or directly in numbers, which is impossible, you actually have to rank them. We'll see all that, right? Okay, so we can proceed. As I told you, it is useful on studying qualitative measures or attributes, something like that. And so you can just call it as a non-parametric version of product moment method. We say non-parametric because, the product moment method uses parameters like standard deviation, covariance, something like those. Okay, so this is the formula. You have to use this formula. This is Spearman's rank coefficient correlation method. Okay, you say 1 minus, this is 6 times the square of the summation of the d's. Now, what do you mean by d? You will be having two variables and you rank them. So d is the difference between the ranks of the corresponding variables, right? Yes. And then we divide by the product of n and the difference between the square of n and 1, right? Okay, so this is what we'll do. All right, the following are the steps in computing Spearman rank correlation. Actually, it's not such number of steps. You just need to know these figures. N is the number of data pairs, which will be obvious from the question. All you need to know is D, but D is the difference between the ranks. So it's obvious that you first need to determine the ranks, take their difference, and then you proceed, right? Okay, so the steps we say rank both sets of data in descending order. Let's say you had the marks 90, 80, 95. You have to rank them in the descending order, right? Maybe let's go to an example here before anything. For example, you have the candidates here. This is A1 result, 76, 90, 55, 74, 74. So you will have to put them in the descending order, in the decreasing order. So you start with the highest and you go to the lowest. So I would have started with 90 here. I'm speaking of A1, right? And then after that 90, I would have gone to 76, and then I would have gone to 74 and 74 again, right? Something like that. So that's what I meant. All right, we can proceed with the steps. So just rank them in the descending order from highest to lowest. For two or more items having equal values, if you have equal values, no worries. Just put one and then the next will follow. And to determine the rank, you will have to take the average, right? So the same rank is to be given is an average rank is determined. Let's say you have 70, two 70s, right? 170, let's say is on number 5, and the other 70 is on number 6. So you take 5 plus 6 divided by 2, and you'll have 5.5. So each of the 70s will have a rank of 5.5, something like that, right? Okay, so after having the ranks, you have to compute the difference between the ranks for variables x and y. I just presume by variables to be x and y. And that difference would constitute this d here. So all we need right now is just the square of this d. That's why we say determine the squares of the differences to determine the d square, right? After that, you sum them and then you apply the formula, something like that. All right, now let's move to the question, to an example. We have to finish this. Okay, let's note this. Sometimes the formula for product moment method can be used on the ranks. Just note this. You can rank the value for the variables and then still use the exact formula for product moment method, right? Of course, it is said that when maybe you have at least three values having the same rank, the product moment method is usually said to give a better result compared to this formula here, but we're not going to deal with that. That was just a note. All right, let's take a look at an example. Consider the marks obtained in A1 and A4 by 8 candidates. Now, presume that A1 and A4 are the subjects the student fit for. So we have 8 candidates, candidate A, B, C, D, E, F, G, and H. And we have the marks for A1 and A4 as you see them. Required, compute the Spearman's rank correlation coefficient between the two subjects, right? Okay, so that's what we need to do here. All right, now we have to go to the solution, and we know that this is the formula. 1 minus 6 summation of this squared over n bracket n squared minus 1. Okay, let us let maybe a1 to be x and then a4 to be presented by y, right? All right. We had 8 candidates. Now I just decided to put the columns here. Instead of A to H, I wrote the numbers here. They will be good for ranking. That's why I'm doing that. So number 1, number 2, number 3, 4, 5, 6, 7, and 8, right? Okay. Instead of A1 marks, we put here X. And these were the marks for A1, 76, 90, 55, 74. You can see them here, right? Yeah. 76, 90, 55, 74, 74. You just copy them as they are first. And then for A4, which is Y, 82, 70 up to 56, right? I just copied 82, 70 up to 56, and here for X. Now, after doing that, you need to rank. Now, before ranking, we said that you have to arrange the marks in the descending order from the highest to the lowest. Now, we start with the order of X. From X here, the highest number is 90, so I would have to stay with 90 first here. And then the next number would be how much? 76, right? Yeah, 76. And then it would be 74. But there are two 74s. So the first 74 and the second. And after 74, which is the next one, we have 60, right? So I would have 60 here. Yeah, but also have another 60. So I have 60 and 60. And then you have remained with 55 and 54. So 55 first and then 54. All right, now after arranging them in the descending order, we are in a pole position now to determine our ranks. Okay, how do we do this? We just start. You have 90 here, right? You have 76. You have 74, 74, 60, something like this, right? Yeah, so at this point, maybe there is something you can do here, right? So if you take a look here, you find out that this 90 is here and this 76 is here. Now, this is just the order. What we are dealing with our numbers. So let's start with 76. 76. 76 is here, and 76 being here, it shows that it is on number 2. You see this? Number 2, and it is alone. So that's why for 76 here, we put number 2. So do not confuse. We do not follow these numbers here. We come back to the numbers here. These are just for ordering, right? So 76 is on rank 2, is ranked second. Okay, we go to 90. 90 come to X order. 90 is here. It is obviously on number 1. So on 90 here, I would say number 1. All right, you go to 55. 55, come and search for 55 here. You would find it here, 55, number 7, right? So on all 55, there are how much? There is just one of them, 55, this one. So it's on rank number 7. And then we have 74, but we have two of them. All right, as for 74 now, if you come to the X order, we have two of them here and here. The first one is on number 3, and the second one is on number 4. So you have to take the average. 3 plus 4 divided by 2. 3 plus 4 equals to 7, and if you divide by 2, 7 divided by 2 would be 3.5, right? So that's why if for 74 here, we have 3.5. And for 74 again here, we have 3.5. Now you proceed. You have your 60 here, and you have two of them. All right, as for 60, you do the same. On the ordering column, the first 60 is on number 5, and the second 60 is on number 6. So I would take 5 plus 6 divided by 2. 5 plus 6 equals to 11. 11 divided by 2 equals to 5.5. I hope you got what I was just trying to entail here, right? I just said that you would say 5 plus 6 and then divided by 2, which gives you 5.5, something like that, right? Yeah, so that's what I wanted you to understand. All right, I hope that we can actually proceed. Okay, so we proceed here and say we have 60. So on first 60, I would have a rank of 5.5, and the second 60 also 5.5. All right, the only number remaining is 55 for x variable, so 54, sorry. If you analyze 54 here, you find out that it is on number 8 and it is alone. So 54 here would have a rank of 8. And we are done with our arrangement for x variable. So you go on and do the same for the y variable. So for y variable, which is here, we can see that the highest number is 82 among all. That's why I started with 82. And then we have 78, but we have two of them. So the first 78 and the second one. And then after 78, we have 70, 70 and 70 again. So we have two 70s, these ones. And after that, we have 56, right? 56, and then we'll have 55, and then at last we'll have 50. So you will do exactly the same. If you start with 82 here, it seems to be on number 1. I mean, 82 here, you just come to the order. Order is here. 82 is the first one, and it is alone, so it would have a rank of 1. And then go on to 70. As for 70, take a look at 70 here. We have two of them. The first 70 is on number 4, and the second one is on number 5. So 4 plus 5, 9 divided by 2, 4.5. So as for 70 here, I would have a rank of 4.5, just like for the other 70, I would have the other 4.5, right? Okay, you go on and proceed. We have 78 here. 78 is here, right here, but also right here. The first 78 is on number 2, and the second one is on number 3. So 2 plus 3 equals to 5 divided by 2, you would have 2.5. So 78 would be ranked 2.5, but also the other 78 would be ranked at 2.5, something like this. All right, you go on and proceed. You have 55 here. 55 is for the white order. You will find it here, and it is alone ranked 7. So 55 here would obviously be ranked 55 here would obviously be ranked 7. And then I have 50. 50 here you have, it is on the 8th position. So 50 would be 8. 70 done it already, 78 done it already, and then we have 56. 56, if you come to the order here, 56 would be here on the 5th row. And so I would say that this 56 here, would be 5th, 6th, this one. So after having done that, I would have everything on the rank of x, but also the rank of y. So all I've remained with is determining the differences. So difference equals to Rx, rank x minus rank y. Of course, it doesn't matter even if you take a rank y minus rank x, because at the end of the day, you're going to square them. And the square of the negative number is a positive number. All right, so you have 2 minus 1, which is 1. 1 squared, 1. Here, 1 minus 4.5 equals negative 3.5. If you do square it, you obtain 12.25. 7 minus 2.5 equals to 4.5. If you do square it, you would have 20.25. 3.5 minus 7 equals negative 3.5. If you do square it, you have 12.25. 3.5 here minus 8, you have negative 4.5. If you square it, you have 20.25. 5.5 minus 4.5 would have 1. The square of 1 would give you 1. And 8 minus 2.5 would have 5.5. And if you do square this, would have 30.25. And lastly, 5.5 minus 6, this would give negative 0.5. And if you do square it, would have 0.25. All right, now as the formula shows you here, you would have to take a sum of the squares of the differences, right? Of the ranks. So you just add them, add these figures here to obtain the sum. 1 plus 12.25 plus 20.25 plus 12.25 plus 20.25 plus 1 plus 30.25 plus 0.25, and this gives you a total of 97.5, right? Yeah, so if you have 97.5, as you can just see here, we say that, all right, now we have the summation of square of d. So if you have the summation of the square of d, we are in a pole position to proceed here, right? Okay, so I would just write my formula here and start plugging in the numbers, right? Yeah, just start plugging in the numbers. So you have 1 here, this one, and then you have 6 times summation of this squared. Summation of this squared equals 97.5 is seen here, right? This one, and then you have n. Now, what is n? N is the number of data pairs. We just count the rows. We had the first data pair, 7682, 97 to the second, 5578 the third, 7455 the fourth. Actually, the numbers are written here, so it's 8. So you can have your 8 here. This is what we have, 8. Yeah, something like that. So 8 squared equals 54 minus 8 times 63, and then we divide. You take 6 times 97.5 divided by this down figure here on the denominator, and then we'd have your R as negative 0.16, negative 0.161. So that would be your value, right? Yeah. So that would be your value. Actually, would be you would have finished everything. So whenever you encounter such a question, just relax and then proceed as appropriate to arrive at your result. Actually, the correlation is negative here, showing that when the marks of one subject increase, the marks of the other decrease. They are in opposite direction, and also the correlation is very, very weak as we see here, right? Okay, if you haven't subscribed, you can do it for regular updates. Thank you very much, and until next time.